Hello, hi, and howdy, everybody. Hey, wanted to show you where we're heading. Just finished up a week with starting the language arts iLearn. Finished chapters 12, lesson 7, moving into chapter 12, lesson 8. More of the same today and tomorrow in preparation for the iLearn. I think we have no class on Wednesday. Quiz coming at you next Monday, so be ready for it. And here we go. Hey folks, today chapter 12, again lesson 8, slope-intercept equation, which often you will hear y equals mx plus b, where m is the, slow down Mr. Cowan, let's let him get there in a minute. Go ahead and pause, take a look at your homework, come on back when you are ready. And moving right along to page 2, pause and come on back. So ladies and gents, this is where we're at. We've been using T-charts to graph. Coming up now, we should be able to graph a line given its slope and y-intercept. We should also be able to write an equation of that line if given its graph. So basically, if you take a look at this visual, if you're given the graph, you should be able to write an equation. If you're given the equation, you should be able to write a graph just by looking at this. And it's not that T-charts are bad, but we think we can come up with a more efficient way. Now, that's the ideal because sooner or later we're going to have a system of two or more equations, and we're going to want to graph them to find the solution that works for two or more equations. But for now, let's just focus on one. Hey, I want to do a brief review, though, of those T-charts, so I'm going to kick it on back. If you wish, you can pause and make up your own T-charts for this. If you don't have a graph paper, don't worry about it. Pause, come on back when you're ready. Now, if you recall, ladies and gents, we almost always use negative, 1, 0, and 1 for our inputs. The only thing that I would be worried of, not worried, but wary perhaps is the better word, if you have a fractional coefficient, maybe instead of using 1, and you can certainly use 1 if you really wish, but maybe you want to use a different number that's a multiple of that denominator so that it will eliminate or cancel out the fraction. You don't have to deal with it anymore. Again, you're welcome to use negative 1, but I think I'll stick to negative 2 for this one. Let's just pause. Come on back to the first equation. Now, if you substitute in a 0, 4 times 0 is, of course, 0, and 0 plus 1, y must be 1. So if your input is 0, your output is 1, and you graph the following point. Now let's go ahead and try it with a different value of 1. Negative 4 times 1 is negative 4, plus 1 is negative 3. So if your input is 1, your output is negative 3. In this case, I kind of like negative 1 because the opposite of a negative makes a positive. 4 plus 1 is 5. So if your input is negative 1, your output is 1, 2, 3, 4, and 5. Now we can go ahead and we can draw a line through these points, or at least as best as we can. Where, of course, just because our ordered pair stops doesn't mean the number of solutions does. There are so many solutions to this. There are billions and billions and billions. So let's make sure that we show that by drawing the arrowheads. And let's come back to the slope and the y-intercept in a moment. All right, pop on down to this fella. Again, we like to input 0 first because, hey, anything times 0 is 0, and 0 minus 3 is negative 3. So when your input is 0, your output is negative 3. I know I'm talking fast, folks, but remember, you can always go back, rewind, slow it down. Here we go. Half of 2 is 1. Go up 1, go down 3, you're in the negatives. Not that far, Mr. Cowan. How about negative 2? So when your input is positive 2, your output is negative 2. And let's wrap it up with one more because half of negative 2 is negative 1. Now, if you start down below water and you go deeper down below water, you should end up at negative 4. Some of you change subtraction into adding the opposite and might be a little easier for you to see. So when your input is negative 2, your output is negative 4. At that point, we go ahead and we draw a line through these points as straight as possible. And just because we only use those 3 inputs, there are billions and billions and billions of solutions. That is why we draw the line. And just because our ordered pair stops, just because our table seems to run out of space, hey, we could go on forever and ever and ever and ever and ever. All right, now let's come on back and take a look at the slope and the y-intercept for both of these lines. The y-intercept sometimes a little easier to see. In this case, the y-intercept is a positive 1, or you may write it as an ordered pair, 0, 1. And the slope is, it appears to go down 4 and right 1, and down 4 and right 1. So I suppose we could write it as negative 4 to 1, or you could just write it as negative 4. Let's go on down to the second one. Again, the y-intercept might be a little quicker to see. You can write it as a ordered pair, or simply write the negative 3. Meanwhile, the slope appears to go up 1 and right 2, up 1 and right 2, up 1 and right 2. 1 to 2 does not divide, nor does it reduce, and a positive divided by a positive is a positive. Hey guys, look at that. And look at that. And if you want, pause right now. Folks, perhaps you have already spotted a pattern, and that's where we're heading. Hey, you can get out a piece of paper, but I do have a separate piece of paper for notes for today. Meanwhile, you'll have a lot of work to do on paper and then another paper to graph those out. So you're going to need loose leaf or notebook paper right next to some graph paper and a third notes piece of paper as well. Pause if you need. Come on back when you're ready. And so if you'd like at this time, you can get that notes page out, but I'm going to do a few things first before we get to example 1. Now, just a reminder that what is slope? Slope is the change, this is the Greek letter delta, which also means change, in the y value. It is the vertical change. So how do you find a change of anything? Why, of course, you subtract. The rise is compared to the run, or the change in the horizontal value, or how do you find the change? You can subtract the two x points. Now, frankly, I could go into this a little longer, but I'm not going to take too much time today. It really doesn't matter. A little disappearing ink here. You could call this the first point and that the second point, or you could switch it around and it's still going to work out. Now, the y-intercept, ladies and gents, is where the graph intersects, some people just say crosses, the y-axis. So you can even, I wonder if I can move the star. No, I can't. You can even put a star on the line and act like it's sliding down, and then bam, it's where it like hits it like a brick wall. That is the y-intercept. In this case, you could write it as an ordered pair, or you could simply note that the y-intercept is the positive 3 value. It's kind of like saying you got $3 and then your money's going down with time. Now, perhaps you noticed, if you didn't, pause the video, rewind back to those two examples that I just did, where I was asking you, do you notice a pattern? I hope so, because the y-intercept is always that constant term at the end. Now, sometimes it's positive, sometimes it's negative. You could write it as plus a negative b, or you could simply write subtract b. It doesn't matter how you say it. The y-intercept is the constant term at the end of a slope-intercept equation. And the slope is the coefficient. For instance, if you went down $4 a day, you can write that, of course, you can write negative 4, and then you would substitute a negative 4, and that is your slope. So please pause the video if you need. Put this right at the top of your paper, where slope-intercept form, the y-intercept goes at the end in place of the b value or term, and the slope goes before the x. It is the coefficient in this equation. Pause if you need. Come on back. So let me show you a real example. If you notice, what is the y-intercept in this case? It is the 3, so you can put it right there at the star. Now, after you place that 1 point, okay, so we know this is a point. I'm going to zoom in a little bit. That's why it looks a little blurry. Now you're going to use the slope and say, all right, so we got $3 to start with, but we go up $2 a day. Okay, so let's write it as a rise and a run. As we previously learned, if you have a slope that is an integer, you can simply put a 1 underneath. After all, 2 divided by 1, still 2. $2 per day, right? Or whatever the case might be. So we're having a rise of positive 2, so we're going to go up 2. And a run of positive 1, so we're going to go to the right 1. And now we can place another point. Maybe instead of a star, I should put a dot, huh? we can place another point on our coordinate plane. Now that we have 2 points, ladies and gents, you may draw a line. Now you need a minimum of 2 points. You know what, Mr. Callan? We're going to do 3 or more. The more points you draw, the straighter your graph will be. So you at least need 2 points. We'll try our best to do 3 or more, greater than or equal to 3 points. And that's one of my examples. So now we get to your examples. On your notes page, we have 4 examples from starting with an equation, creating a graph. Then we'll have 4 more examples starting with a graph and creating or writing its equation. All right, so it's our turn. First and foremost, let's drag a star to the b value, the starting value. If x is 0, anything times 0 is 0. Hey, look what it says, y equals 5. If you would like, until you get the hang of it, you may write it as an ordered pair, but we're going to look at 0, 1, 2, 3, 4, 5. Sooner or later, I'll get rid of the stars. I really would suggest you guys just draw points. That's my suggestion. You can ignore it if you want. All right, now we're going to drag a star using the slope, and the slope is very similar to the last example. So we have a rise of +2 and a run of +1. So let's go ahead with a little disappearing ink here. Rise of +2 and a run of +1. And we can now draw a new point. Let's do it again, shall we? Rise of +2 and a run of +1. And we have another point. Now notice at this time, if I try to go up 2, I'm off the graph. But we have discussed this before, that we could go in the exact opposite direction. Check this out. What do we know about the opposite of a negative? Well, in this case, the opposite of a negative is still a positive slope. So we can go down 2 and to the left 1 and find another point. And you can keep going as many times as you want, down 2 and left 1, down 2 and left 1, down 2 and left 1, and so on and so on. Now at this point, we're going to go ahead and we're going to draw a line. See if I can stretch this guy out. And there we are, ladies and gents. So you've taken an equation and you've turned it into a line without doing a t-chart. Now, if you do a t-chart, I would fully expect, and you should as well, that all these inputs and outputs will be points on this line. They might be parts, pieces, portions. They might be nice, pretty integers, but they should be solutions to this equation. And remember, please, there are so many solutions, millions and millions and billions and billions and trillions, and yeah, infinitely many, that instead of sitting there and drawing trillions of points, that, ladies and gents, is why we draw a line. Always going to bring you back to the idea that a solution is a number or numbers that makes a statement true. Onward to example 2. Y is equal to -4x plus 2. Let's go ahead and start off with that y-intercept. If x is 0, anything times 0 is 0, then y must be 2. So we go ahead and we draw a y-intercept right at the point 0, 2. I might stop using these stars because they're kind of driving me nuts, to be honest. So let's go ahead with some little thicker than that. There we go. All right, now let's go ahead and use a different color. What do we do for the slope? Now I'm going to see that slope of -4. -4, we can put a 1 under it. After all, a positive divided by, that looks pretty ugly, doesn't it? Let's just go back to smaller. -4 divided by 1, but you know what? We could also go in the opposite direction. We could go up 4 and left 1. Now I'm going to start with the most basic thing. So little disappearing ink here. Let's go ahead and go a rise, or should I say a fall of -4, 1 and 2, 3 and 4, and a run of +1. And now we have a nice new point. Let's do it again. Rise of -4, 1 and 2, 3 and 4 down. Run of +1. I noticed my points disappeared. And let's just go again, down 4 and to the right 1. Now we can also use the inverse or opposite direction. So let's do it. Go up 1 and 2, 3 and 4, and go to the left 1. And there's a new point. And let's do it again. Up 1, 2, 3, 4, go to the left 1. We know that just because we drew some nice points doesn't mean there's not only those points. There are billions and billions and trillions of values that would make this equation a true statement. And there you have it, ladies and gents. The equation, y is equal to 4x, negative 4x plus 2, and its correlated line on the coordinate plane with all of the solutions for that equation. Example 3, if you want, pause, try it on your own. Come on back when you're ready. I'm going to note here that the y-intercept is -1, and if you think about it, that would be 0, -1. So we go to our graph and we plot the point at 0, -1. Now let's go ahead and talk about our slope. Our slope appears to be up 1 and to the right 2, but don't forget, you may go in the exact opposite direction and still be okay. So we can go up 1 and to the right 2, and there's our first point. And we can do it again. We can go up 1 and to the right 2, and there's our next point. And as you can see, we have lots of space to put more points. Up 1 and right 2, up 1 and right 2, up 1 and right 2. Notice that I choose to go as far through the graph as I can to make sure my line is good and straight. Now that being said, we can also have a nice negative value because the opposite of a negative is still a positive slope. So we can go down 1 and to the left 2 and find more points. Down 1 and left 2, down 1 and left 2, down 1 and left 2, and so on and so on. So at this point, we take our line and we draw it through that graph. Oh, that's not going to work. That's going to be good enough for me. So now we have drawn the line that displays all the possible solutions for the equation y is equal to 1/2 of x subtract 1. Last one again, folks. Go ahead if you wish. Pause. Put it on your own notes. Come on back when you're ready. First things first, I see a y-intercept of -3. I go to my graph and I plot where on that y-axis. Remember, you're up and down here. Where on that y-axis? All right, there's 0, -3. Now we can use our slope. If the negative is out in front, what I will often do is, I don't know, it's just my own personal preference. I tend to put it up top because the opposite of a positive is a negative. However, to find more values, let's do positive over a negative. But we'll start with this guy. -2 to 3, so a rise of -2, or should I say a fall of -2, will go down 2, 1, 2, and then a run of +3, 1, 2, 3. Notice I always use disappearing ink there, folks. If you don't, please go back and do it very lightly and then erase your little hops, jumps, whatever you want to call them. Let's go again, go down 2 and to the right 3, go down 2 and to the right 3, and before you know it, I'm going to be off of the graph. But don't forget that we can also have a rise of +2 and a run of -3. We still have the opposite of a positive is a negative. So we can go up 2 and we can go to the left 3. And there she is. And we can go up 2 and left 3. 1, 2, 3. And we can go up 2 and left 3 again. And just like that, we have a beautiful set of points that will lead us to be able to draw the line. And of course, the line describes the infinite number of points, x values and y values, that would make this equation y equals 2x, -2/3 x minus 3, a true statement. So folks, right there, we've done 4 examples of taking an equation and creating a graph. Coming up, we're going to go in the opposite direction. We're going to take a graph and turn it into an equation. Now, it's kind of a long video, so if you want, you can actually pause the video and go start up the front page of the homework assignment and then come back when you're ready to go in the opposite direction. So as such, we're going to write the equation of the line that is graphed. First step, I always feel like the best thing to do is to find the y-intercept. So if I take a star and put it at the top of the graph and let it slide on down, bam, there she is. Of course, I prefer to put big old points. And when I look at that, it appears that the point is 0, 3, or perhaps we should just say a positive 3. Now with that in mind, I can immediately put that y-intercept into the equation. But the question that remains is, what about the slope? In order to find a slope, you must have at least 2 points, ladies and gents. So what I'm going to do now is I'm going to drag the star, or perhaps I'll just use a point, and I'm going to find another nice point, and I do want it to be a nice one, and here's what I mean. Boy, I wish I could zoom in a little bit. What I don't want to do is find a point that looks like this. Because what is that? Is that 1.5? Is it 1 2/5? Is it 1.4068? We don't know. So when you're looking for points, please make sure they are integer values, both the x-coordinate and the y-coordinate. Now, lucky for us in this case, there's all sorts of them. There's this one, and there's this one, and there's this one, and this one, and this one. There's a lot. Now you may use anything because this will be a little kickback to what we've already talked about. What if I use these 2 points? Well, it looks like it has a rise of positive 3 and a run of positive 3. But somebody's saying, well, Mr. Cowan, what if I don't like those points? What if I want to use these ones? Well, it looks like that goes up 2 and to the right 2. Well, Mr. Cowan, I don't like any of those points, and I'm going to start from way up here. I'm going to go down 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, and then I'm going to go to the left. Hey, guess what, folks? What do you notice about all those ratios? They're all the same relationship. They're all proportional. Even this negative, the opposite of a negative, is a positive. So in this case, you may write 1 to 1, or you may just write 1 whole. And so now we have found the equation that is described by this line, the equation that has all the solutions of that line, y is equal to 1x plus 3. Let's go on to the next example. Just follow my lead if you would be so kind. First, we're going to go ahead and put that star on the slide and slide it on down. Bam, there she is. So it appears that the y-intercept would be 1, 2, 3, positive 4. Sooner or later, we'll get to a negative. Don't worry, have no fear. It'll happen. Now let's go ahead and find another value by continuing to slide down. Now I'm going to keep going down, although you could probably go up. Ooh, there's one. I almost said down here, but it's just a little to the right of positive 1, and so therefore you couldn't figure it out. But again, you will notice a large number of points, and you can use any of those, folks. Now, let me just use the one that I originally used. And so let's find a rise, or should I say a fall, because this one seems to go down. And then it goes 1 to the right, which makes it positive. A rise of negative 3, a run of positive 1. Well, shoot. 3 divided by 1, you can just write as an integer. The opposite of a positive is a negative. And so in this case, we have a slope of negative 3. Y is equal to negative 3x plus 4 is the equation that you see graphed. 2 more examples if you want. Stop. Come on back when you're ready. First things first, let's go ahead and slide on down that line until we hit the y-intercept. Bam, I'm seeing negative 2. You can write it as an ordered pair if you wish, but really it's the negative 2 that's going to help us. Now let's go ahead and identify more points that we can use. Now I got to be careful here. You know what? Just for kicks, I see the one way up here. That one looks great. So I'm seeing a rise of 1, 2, 3, 4, 5, 6. And it goes up, so it's positive. I'm seeing a run of 1, 2, 3, and it goes to the right. So it's positive. So I'm seeing a rise of 6 and a run of 3, which reduces to 2 to 1, or you may just simply use 2 as the slope. And so there is one way to write the equation. Another way, you may simply write subtract 2. Either of those is acceptable. Students with the strongest skills should be able to write it both ways. There is the equation, ladies and gents. Y is equal to 2x and a negative 2. You probably could have seen, if I use a little disappearing ink here, up 2 and right 1 and up 2 and right 1 and up 2 and right 1, 2 to 1, 2 to 1, 2 to 1. So that would explain where that 2 to 1 came from. Onward, pause if you want, come on back when you're ready. So take that star, slide it on down until, bam, it hits the y-intercept. In this case, it's going to be a positive 4. And of course, it helps if it doesn't disappear. Onward we go. Let's find another point. Got to be really careful, Mr. Callan. All right, there's one. That's a nice one. So this one rises, or should I say falls, negative 1. And then 1, 2, 3. And lest you forget, what if somebody went the other direction? A positive 1 up, and then a negative. Well, guess what, folks? That is the same amount. 1 to 3 neither divides nor reduces. The opposite of a positive is a negative, so we have a slope of negative 1/3. Final equation, y is equal to negative 1 to 3x plus 4. That's what I have for you today, ladies and gents. Kind of a longer notes, but I hope that was helpful. I hope you are going to enjoy graphing lines with or without t-charts. Assignment number 10, please remember that the first part in the book is going to go very fast. It basically is going to say, identify what's the slope, what's the y-intercept, write an equation. The next part might take a little longer, but you'll be okay. Go back after you finish 5 through 29 and then graph out 5 through 20 and 27 to 29. Take care, folks. Do well, and let's grow.